Hello friends, welcome back. Hearty welcome to you. In this session, let's look at how to find out the derivative of product of two functions. That means we know that two functions are already differentiable. They have derivatives existing at x. We want to find out what is the derivative of product of these two functions. For that, we will start with same definition whatever we did earlier. UV are two functions which are mapped from I to R, where I is an interval on R, and u and v are differentiable at x. We want to find out what is the derivative of product of these two functions at x. So I will say f equal to u plus v. Then you can see f of x plus h will be equal to u of x plus h into v of x plus h. Not only that, f of x will be equal to u of x into v of x. So we know the definition of derivative of is equal to derivative of f of x, f dash x equal to limit h tends to 0 f of x plus h minus f of x divided by h. So this is equal to, if I substitute the values, I will have u of x plus h into v of x plus h minus u of x into v of x divided by h, and we have limit here. So let me just put it down, equal to limit of h tends to 0. Now you see here what I will try to do. The whole idea is to express the derivative of product of these two functions into individual derivatives or individual functions, because we know the function, we also know the derivative of the individual functions. We know what is u, we also know the derivative of u, we know v, we know derivative of v. So how I can express f in terms of u, u dash, v dash, that is what we want to find it out. So what I will do little bit manipulation here. I will try to add one term and subtract one term. Have a look at that. I will write down limit of h tends to 0 u of x plus h into v of x plus h. Now here I will add and subtract one term. The term is minus of u of x plus h into v of x plus u of x plus h into v of x minus u of x into v of x. So if you observe, I have just added that term and I have subtracted it. This whole thing I have to divide by h now. What I did is I have added this term and I also have subtracted this term. You can think about it why I have done that, because if I have added and subtracted that term, then I can take u of x power h common, then I can convert the remaining terms into v dash. Similarly, I can take v common in the remaining two terms and make the other one as u dash. That's the whole idea. So the next step will be limit of h tends to 0. Now we will take common here. We will say u of x plus h. I will take it common. So I am left with v of x plus h. That is, this term is over, where I have u of x plus h here. So if I take that out, I will have v of x divided by h plus, again I will have limit h tends to 0. Now you can see the remaining two terms in which v power v of x is common. So I can say v of x into u of x plus h minus u of x divided by h. Now this is nothing but product of limits, which you can write them as separately. Limit of h tends to 0, u of x plus h will be nothing but equal to u of x, and limit of h tends to 0, v of x plus h minus of vx by h is nothing but v dash x. We know that's a definition of derivative. Similarly, we have v of x here, and limit h tends to 0, u of x plus h minus u of x by h is nothing but equal to u dash x. So, suppose we have been given a function which is nothing but product of two functions, then what you can do, write down the first function multiplied by the derivative of the second function, plus write down the second function and multiply with the derivative of the first function. So it's like first u v dash, then v u dash. So we can see now that, let's do one example on that. Just before that, let me repeat this again. We have been given that two functions u, v are differentiable at x. Now suppose I have been given a function f which is equal to not u plus v, that's actually u into v. I am dumb sometimes, most of the times maybe. U into v. So we have to find out how we can express the derivative of this f u into v in terms of individual derivatives and functions. So for that we have found what is f of x plus h, f of x. Then we according to the definition of f dash x, it should be f of x plus h minus of f of x by h. But what I did is I added and subtracted one term just to make sure that I can manipulate them into individual derivatives. So I have added u of x plus h into v power x, and I have subtracted it again so that they will cancel it out. Now I can take them separately. I can take from the first two u of x plus h common, and from the second one I can take v of x. Now if you look at this one, this can be written as one more step where you can say this is limit h tends to 0 u of x plus h into limit h tends to 0 v of x plus h minus v of x by h. We know that u of x is continuous because it's differentiable. So u of x plus h as h tends to 0 is u of x. And this is definition of derivative. So it is v dash x plus vx into u dash x. So let's do one example. Let us say the function for which we have to find out the derivative is x into log x. You can see now x, you know how to find out the derivative of x. It is 1. X to the power of 1 equal to 1 into x to the power of 1 minus 1, that's 1. Log x, it's nothing but equal to 1 by x. So what we will do now, this is nothing but we have to find out the derivative of x into log x whole to the power of, we want derivative. So I will say first x into log x, I have to do the derivative, or I can say d by dx of log x, anything is fine. Let me write that way in the second one. Then v is log of x into d by dx of x. So you can see this is u into v dash plus v into u dash. Either you do log of x whole to the power of the dash or d by dx of log x, it's the same thing. So we'll go to the next step. X into log of x differentiation is 1 by x. We just seen that earlier. Log of x will be as it is. Derivative of x dx by dx is 1. So the answer is x will cancel. You will have 1 plus log x. Let's do one more problem. The function is x square into e power x. So we will try to find out the derivative of x square e power x whole thing. So first thing I have to write the first function, that is x square into e power x, I have to find out the derivative, plus second function is e power x, that I have to multiply with the derivative of x square. Now x square as it is, e power x derivative you know is e power x only, we just checked that, and e power x you multiply with x square derivative, x to the power of n differentiation equal to n into x to the power of n minus 1, n equal to 2, so 2 into x to the power of 2 minus 1, that is 2x. So this is equal to x square e power x plus e power x into 2 power x, or can I say e power x into x square plus 2 power x. That's the derivative of x square into e power x. So you can see, whenever you have to find out the derivative of product of two functions, you can apply this formula which says that take the first function, multiply with the derivative of the second, then add it up to second function multiplied by derivative of the first. So in the next session we will see how to find out the quotient of two functions. That means instead of uv they are like u by v, then how to find out the derivative of them. So we'll look into that in the next session. Thanks for your time. Bye for now.